Alright, hello everyone. This is C# 103 Week 2. I'm going to be here, and so will Mr. Gavin.
Hello, Mr. Nelson and Mr. Peoples.
Yes, hello, Mr. Peoples.
And Mr. and Mrs. People. There we go.
Yes. Okay, so today's going to be a fun little day. What we're going to be doing is we're going to be covering generics. And we're going to be looking at generics, what they are, what we can use them for. And then we're going to be combining generics with extension methods, interfaces, and iterator blocks, and actually look at a very important library that's available to us in the .NET framework called LINQ. So the first thing I want to go ahead and do is do a quick review over delegates, lambdas, and the iterator block. If anybody has any specific questions about delegates, lambdas, or the iterator block, now is the time to ask them, because that knowledge is going to be very, very important as we move forward with what we're going to be doing today, and especially understanding LINQ.
Can you remind me how to make an iterator? Because I was trying to remember earlier.
All right, so
there's a question.
What an iterator block is an iterator block is simply a method that returns an IEnumerable. So for example, I have an iterator block right here called my iterator block, and for it, inside of it has a for loop from 0 to 10, or sorry, 0 to 9, and every iteration of that for loop, it yields execution back to the caller and returns the result I squared. So to use the iterator block, we simply have to say for each var blah in my iterator block, invoke it as a method, and then we can write out our returned results. So now if I were to run this, we get 0 through 81. Not only that, we can also pass in arguments into our iterator block. So for example, if I make my iterator block take in a from and a to, I can now say from I equals from I smaller than or equal to 2. Now I can say I want all the numbers between 1 and 200. And that's what we get. So iterator blocks were covered in the last week of C# 102. And this is just a quick rundown. Are people, hold on. Can you nest the iterator blocks? I'm not sure what you mean by that. As in, if I did something like var static IEnumerable of int filter min int min that took in an IEnumerable of int source, looped over source, filtered each one. So if item is greater than min, then yield return item. Now what I can do is, if I also make my iterator block, instead of saying from and to, let's say I take in an IEnumerable in source. Instead of doing this, I said for each var I in source. Now because I have two iterator blocks that take in an IEnumerable of source and return an IEnumerable, what I can now do is chain them together. So for example, var items equals new list of int 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Missing a comma right there. And now I can go ahead and chain them together. I can say, let's say we do my iterator block, and then as the first argument to my iterator block, we pass in filter min. And as the argument to filter min, we pass in items, and we specify the minimum as maybe 6. And then we go ahead and execute this code. Notice how I've chained together two iterator blocks by threading through an IEnumerable of source, both as the first parameter to each one of the methods and as the result.
And Wolf, it's because he's returning the square from the method. He's returning I times I, not just I. So 200 times 200 is 400,000. 40,000 even.
Yeah. And as far as was yield covered in 102, still watching 102, and I don't want to go asking about it, but I don't remember seeing that all last week. It was on the last week. The final week of 102, we sort of digressed into iterator blocks. Okay, are there any more questions about this stuff? Because now we're going to go ahead and talk about, quickly recap delegates and lambdas. And then we're going to move on to generics, and then we're going to tie everything together. Okay. So delegates and lambdas should be pretty straightforward. We talked about being able to pass methods as parameters, or more appropriately, we talked about being able to use methods as what are called or referred to in programming as first-class functions. First-class functions being functions that can be treated as if they were data, copied around, worked against, invoked later, and so on. So for example, if I wrote a method, like let's say I'm working in a database thing and I have a inTransaction method. And what the inTransaction method does is it takes in an action, which remember is a parameterless delegate that returns void. And inTransaction, what it first does is does a bunch of crazy database transaction logic, then invokes action, and then either commits the transaction if an exception was caught, or if an exception wasn't caught. Otherwise, rolls it back. So what we have here is we can sandwich our code that we pass in. We can sort of abstract away the actual logic that does things and sandwich it in between a bunch of other logic. So now what I can do is I can say inTransaction and pass in a lambda. In this case, a parameterless multi-line lambda, and I can say do stuff with database, blah, 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 blah. And I can prove that it's running by saying doing stuff with database, and then I can say console write line init transaction, and then at the end I can say console write line clean up transaction. And then if I were to invoke this code, we'll see init transaction, doing stuff with database, clean up transaction. And so we're able to sort of sandwich our code, and it really increases the reusability of our methods, because now we don't have to worry about other concerns that our logic may not necessarily care about.
Very nice.
As far as code injection, I'm not familiar with that term. I mean, I can infer its meaning based off the two words used, but I would, although I'm not ridiculously familiar with that concern, or with that term itself, I think it has something to do with aspect-oriented programming, where aspect-oriented programming does things similar to what this does, but it does it by actually going in and rewriting your program.
It's a code injection. To my mind, it's somewhere between this and what you were doing with Antler, for instance, where it's actually building classes for you, and
and then in aspect-oriented programming, what it does is it's on the similar vein, but sort of in reverse, where you write a program and you decorate parts of your program with attributes, and then you run it through an aspect-oriented programming library, and then it rewrites your code, injecting things that wasn't in the original source.
Did you see the question I flagged up in green earlier?
Nelson, can you overload events and or delegates? You may overload events, even though that doesn't necessarily make any sense. Actually, well, to be fair, I've never overloaded an event before, but I don't see why you shouldn't be able to. So let's go ahead and go on a quick little adventure and see if we can overload events.
Did you say adventure?
Yes.
I thought you just...
Oh, wait a sec, you said overload, not override. Did you mean override or overload? Because you can override events, because events are not fields. They're fields and methods. And a delegate you couldn't override because it's a Like Segfault said, a delegate is just a field.
He says he meant overload.
So overload, you mean you shouldn't be, you won't be able to. So for example, you won't be able to say event action int hey. So notice how there's now two definitions of hey. Think about it like properties. You can't overload a property. And the reason you can't overload a property is because a property can't take in parameters. The only way you can overload something is in the context of something that takes in parameters, and you have the parameter list be different. So that's why you can overload these methods. Now, what may be counterintuitive about this is you might look at line 14 and say, well, that's a delegate that takes in a action int is a delegate that takes in a different parameter list than action. Why shouldn't you be able to overload it? Well, the reason behind that is that an event is not a field. It's not data. An event is just two methods. And these two methods that are generated, the add method and the remove method for both of these events will have the same signatures, regardless of what the delegate type is.
You can, due to the way you actually invoke and use events, you essentially build overloads for them each time anyway, depending on what you plus equals.
Right, and
conceptually, obviously it's not this, but conceptually that's what you're building up a list of functionality to go through.
Right.
That's specific to that particular. Or am I talking gibberish? You don't sound convinced.
I'm slightly confused, but then again, my mind is muddy right now.
Segfault sees my point. That's a worry. I must be talking gibberish. Continue.
Okay. So, does anybody have any questions about... Well, you can't overload a delegate, period. Because you just can't. A delegate has to have a name. And overloading a delegate doesn't make any sense because a delegate is a type, not an actual member of a class. A delegate is a type just like a class is. So saying, can you overload a delegate is like saying, can you overload a class? Which doesn't make sense. An event, however, is going to always be a member of a type, as opposed to a type itself.
Wolf, do you have some particular situation in mind that your conceived answer would be to, or are you just pondering in general?
We did have one quick question about, so the question was, can you use params as a delegate parameter? And the answer is going to be yes. However, you won't be able to use any of the built-in delegate types, action or func, with the concept of being a params. If you wanted to have a delegate that supported params, you would have to define your own delegate type and not use one of the existing ones. Okay, so is everybody good with delegates, lambdas, and iterator blocks? I would take that as a yes. Okay, so let's go ahead and talk about generics. What are generics? Well, we've actually used generics a lot recently. A lot.
We've kind of used the specific part of generics. We've used specific implementations of generics.
Yep. We've used what are called excuse me, closed types. In .NET, there are two kinds of types, open types and closed types. A closed type is a type that either has no generic parameters or it has the list of generic parameters have been applied. Meaning that list of int is a closed type that provides the int generic parameter to the list class. So when I say something like, no, action is not doesn't mean parameterless. Action means that actions don't return anything. There are a bunch of different action overloads that take in a bunch of stuff as parameters. Funcs can return things. The specific action was parameterless. This action delegate is parameterless, but it's not the only action delegate. There's also this action delegate, where this action delegate takes in an int, and this action delegate takes in two ints, and so on and so on.
If you're confusing the two and the definitions of the two in your head, because it's one of those things where there's, just think about what the names actually mean. You've got action and function. And a function is something of the form f of x equals some function of x. You need to return the function answer, whereas the action does an action to something. So no return required.
Yeah, and funcs have to return something. There's no func delegate that doesn't take in any generic parameters. The simplest func delegate takes in one generic parameter, and that's always going to be the return type for the delegate. No, you cannot use void as a generic parameter to anything, or a generic argument to anything. Okay, so yeah, so delegates, or not delegates, generics. So list of int is a type. List of float is another type. List of string is a third type. These are all different types, and we know that they're different types because, for example, if I have a method that takes in a list of ints, I can pass in a list of int because that's one type. We know that they're the same type, or at least, to be completely technical, we know that the items variable has a implicit conversion to the woe parameter defined on line 21. But if we try to invoke this with a list of anything else, such as items2, you'll notice we get a nice little error, because there is no conversion between a list of float and a list of int. They are two different types entirely.
But Nelson, they're both very similar, and they seem to do the same sorts of things to whatever you put in them. Surely there must be some more generic form of them.
Right. Well, that's what generics are. Generics are a way to define what's called an open type, and then construct as many combinations of generic parameters that you can theoretically come up with, a variety of other types that are based off that one open type. You cannot instantiate a list of T. And when I say a list of T, let's get some terminology down. When I say list of T, and sometimes I'll write this simply as list with that, but whenever I speak it, I'll always say list of T. This is the closed type. In fact, I wonder if we can even jump into the implementation of list, and you notice that here's the class list, and notice how it's defined up here. It says public class list of T. Now the of that I'm saying corresponds to the angle brackets. The angle brackets define genericism. So this is a list of T. This list class can be, you can apply any type you want to this T parameter and construct an entirely new type. So that's why intuitively people think of, well, list of int, list of float, list of string. That sounds, rather straightforward, I guess you could say. It's not a very difficult concept to show a beginner that, well, if you provide int into these little angle brackets, that means the only thing you can place in the list is ints. And you'll notice that in the IntelliSense, if I do items.add, notice how the IntelliSense pops up. this isn't list of t add, this is list of int add. And it says list of int add int item. Whereas if I had done items2 dot and done add, notice how it says list of float dot add float. So we're going to be looking at the mechanisms that we can actually use to create open types and how we can apply those types to do certain things in our code. So how ridiculously confused is everybody at this point? Now, I should probably back up right now and talk about what generics are, because I just wanted to point out, well, what generics are in a little bit more formal sense, because what I just pointed out is something that you have all been using already that is a genericized type. It is, list of t is an open type, and we've been using that all around our code. So I just wanted to give people an idea of where I was going with the concept of generics. But to back up, to anybody familiar with C++, templates in C++ will behave similarly to generics in C#. However, generics in C# are a lot more powerful. Actually, some people might say the reverse is true, because templates in C++ allow you to do things that you shouldn't ever be able to do, and in fact are the basis of getting, you can do fun stuff with generics or templates in C++, like using definitions of types. You can create code that like calculate sign, but calculate sign during compilation by using the compiler, the way that the compiler analyzes your type engine. But then again, why would you ever do that for production use? So some people might say that C++ templates are more powerful because they're less restrictive, when I believe the opposite is to be true. Generics in C# behave very differently than templates in C++, especially at a runtime level. And this is also a difference between generics in C# and generics in Java. See, generics in Java and generics in C++ are only compiler time components. They don't exist at the runtime. They are only used to validate the type safety of your code and little else. Well, other than the fun little tricks you can do with them, sure, but they're not used for really anything else. In C#, however, generic types actually exist during runtime, which means we can reflect over generic types, we can instantiate generic types, we can construct generic types, and do that all during runtime. And it provides a lot. Not only does it reduce the amount of size of your executable, because like I said in C++, when you say I want a vector of int and then I want a vector of float, C++ will literally go out, take the definition of vector of t, copy and paste it, and then copy and paste the word int wherever t was found. Meaning that using sufficiently enough generic types in C++ will lead to your executable being very bloated. But generics in C# are very powerful. Why are they named differently? I don't know why they're named differently, but they are. I like the word generics more than templates, personally.
I think templates seems much... Well, I was just pondering on the fact that they are doing... It's much the same concept, generics to specifics, as, abstract classes to concrete classes. You specify the abstract, and then you implement the concrete version. And similarly with generics, you write the type generically, but then implement it concretely.
And maybe they're named differently in C++, they're named as templates is because they actually literally do behave like templates. Like I said earlier, whenever the C++ compiler sees you're using a vector of int, it literally goes to the definition of the vector class, literally copies and pastes it, and replace the generic or the template parameter with whatever you specified. Which of course has the drawback of code bloat or executable bloat.
We've had a couple of questions about memory usage and allocation and performance.
What about performance, because of all the copying C# has to do? Generics do not incur a performance penalty on anything other than maybe compilation, but the C# compiler is ridiculously fast anyway. You won't notice a difference. During runtime, it's not going to impede any performance. However, well, that's not necessarily true. There are instances where constructing a generic type will lead the jitter to have to perform more operations on the first instance of finding a applied generic or a closed generic type, but those performance issues are entirely negligible. They're not something you should concern yourself with because they're not. It's not like invoking a method on a generic type is going to be any slower. It's not like instantiating a generic type is going to be any slower. The only things that might be slower during runtime is the first time that you instantiate a generic type of a type that hasn't been instantiated yet. The jitter will have to do a little bit of extra work. But typically the jitter doesn't impact performance at all. How is the memory allocated if generics exist during runtime? How much memory is allocated to the generic objects? The exact same amount of memory that would be allocated to a non-generic object. When we instantiate, when at runtime, when these types are constructed for us, they turn into just normal classes. And that means that the performance characteristics of these classes is the exact same as the performance characteristics of any other class. However, as far as performance and generics are concerned, it's actually funny, but generics can actually increase performance significantly during a few different types of operations. And I'm going to be going over that in a second. So a little bit of history behind generics. What happened was in C# 1, the C# development team did not have enough time to implement generics into the C# language, even though they really, really wanted to. So as a result, C# 1 was entirely generics-less. Didn't have any concept of generics, which means that you, instead of doing a new list event, you did stuff like, let me go ahead and import a namespace that I hope I would never have to import again, using system.collections. You would use something called an array list. And an array list looks like a list, except for instead of adding in ints or whatever, you add in objects. Which means you can add any conceivable type into an array list. And that was the dynamic resizing list functionality of C# 1. And this caused a ridiculous amount of problems, an insane amount of problems. Some are very apparent, some aren't. The most apparent problem is that we have no type safety whatsoever. There's no type safety. There's no constraint that this array list must have must be of homogeneous types because, well, there's no generics. Which means that looping over array lists was a very scary thing. So if I said for each int item in list and ran this code, it gets to 1, 2, 3, and then I get an invalid cast exception. So every time that you enumerated over an array list, you were in a position where you could quite easily have your program be crashed if another developer had done something stupid. So you had to pay really, really close attention to the types you're adding into array lists. Furthermore, passing array lists around as parameters and using array lists as properties became very problematic because there was no implicit documentation as to what types are appropriate for the array list. So those are the most obvious problems with a non-genericized container. One of the non-obvious problems with a non-genericized container is... Okay, I'm going to go ahead and do something real fast. 1, 2, 3, 4, 5, 6, blah, blah, blah. Blah, blah, blah. I'm going to call this list and this array list. Array list. Now, I'm sure all of you here will be able to guess exactly what the correct answer is. But I would like it if people could figure out or kind of think about why it's true. And one of these for each loops will perform significantly faster than the other. There's a very specific reason why it is, and we haven't actually gone over this reason yet, but maybe you guys have heard of what I'm going to be talking about. And segfault, okay, we did actually get a correct answer. I was going to say segfault's welcome to answer this one because I highly doubted anyone else would be able to answer, but then we already got a correct answer. Okay, the reason why our... You what?
I was going to say what Sandra said. On account of not having heard the terms that Jim said.
That actually comes very, very close to the specifics of what Jim said.
Cool.
And that is that when we enumerate over our list, at compile time, the getEnumerator method, or the current member of the enumerator is an int. And that's significant because instead of, when we have an int, copying it from an int to an int is a very cheap operation because everything is known. However, in this case, what we have is casting going on, where the current property of our array list's enumerator is an object. And casting an int, or casting an object back into an int, as well as casting an int into an object, will always result in an operation called boxing or unboxing. We haven't really talked about value types versus reference types quite at all, really, but we will be probably in the next week here. However, just a quick rundown, when you have value types such as ints, floats, doubles, any structures, any enumerations, those are all, by performance reasons, attempted to be placed on the method stack frame. Now, that's not always the case. There are plenty of instances where value types get placed onto the heap, but by default they get placed onto the stack, which increases performance substantially. However, when you cast a value object into an object, remember all types in C# inherit from object, including ints. What happens is you cannot have an object reference, as in a variable typed to the object type, pointing to something that's on the stack. So what you have to do is you have to box that value type. And when you box the value type, it takes the value of that value type, copies it onto the heap, creates a fully fledged object reference on the heap, and then returns that reference. And the process of boxing is very expensive. Then when you want to use the value type, typically what's going to happen is you are going to unbox it, which is what happens here on line 19. We are unboxing each one of these items. See, every single one of these values is inevitably stored somewhere in dynamic memory because they're being added to an object. They're being cast to an object, or sorry, they're not being cast to an object, they're being converted into an object, which results in boxing. And then when we pull them out of the array list, we get unboxing. So there's actually fairly sizable performance difference between these two bits of code, especially when you use a lot of array lists with a lot of value types.
Can you use var with array list?
Yes. What you would get back are objects. So notice how, in fact, this would not...
Yeah, actually, when I... Sorry, I didn't even notice that you hadn't, if you see what I mean.
Yeah, typically I don't, but
for
this example I had to specify the int, otherwise, otherwise I wouldn't be able to demonstrate the issues from this. But if we wanted to do, like for example, if I did use implicit typing right here on line 19, the code would still work because we're just printing out boxed integers. But if I wanted to, let's say, perform an operation on those integers, like maybe item times 2, that's not going to work because I'm going to need an int type. I'm going to need the variable within the for each loop being typed to int.
Yeah.
But an array list will win the for each race if there are only objects in the list, right? Nope. There's no substantial performance difference during runtime between a generic type and a non-generic type. So because list and array list both use the same algorithm, they both use dynamically sizing arrays, just like the vector type in C++. There's no difference in the performance characteristics between the two, other than the issue of boxing and unboxing value types. So yeah, array lists suck. And just for completeness,
hurrah.
The hash table is the equivalent to the dictionary, the genericized dictionary. So again, just for completeness. Okay, so Microsoft realized that, especially in regards to collections. Now, this was the primary concern when Microsoft develop generics. Because both generics and templates, their number one use case is collections. Now, it might seem trivial to be, oh, you know, they spent what? How many years between C# 1 and 2? Like 4 or 5? C# 1 was 2001, C# 2 was 2006. So yeah, Microsoft spent 5 years making collections better. Well, that's kind of true because generics, their primary use case is collections, although as we'll see, there's many other applications to them. But Microsoft really wanted to fix this problem. So they created this, there's actually again, I really like programming language history, and I follow a lot of blogs for people who are on the C# development team, and they'll sometimes digress into their experience with putting generics into the language and talk about, you know, how they had like a task force in some university putting them together, and it was a really interesting story to hear how this feature was implemented, but that's kind of irrelevant. That's what they did. They implemented generics. Does C# have the dodgy angle bracket bug? The answer is no. And what the question meant was, in C++, actually I want to clarify, in C++ versions that were earlier than the latest standard that was standardized recently, this was a compile time error. And can anyone guess why? Can anyone guess why this would be a compiler time error in a language? Now, of course, Segfault answered it. Ooh, Jim got it again, too. Yes, the answer is if a language interprets this symbol as a bit shift operator as opposed to the closing brackets for the generic parameters, then it won't be able to compile that statement. And yes, C++ recently did fix this problem. And C# never had it to begin with. Okay, so yeah. So generics are awesome, and Microsoft invented, they spent a lot of time, basically the difference between C# 1 and C# 2 was primarily generics. Not only did they build in generics very well, not only into the compiler, but also into the runtime, and they're an incredibly powerful tool. So let's go ahead and quickly back up. We're going to see a lot of examples later today about where generics actually do provide some really excellent features that we can take advantage of. But unfortunately, this is one of those instances where generics are a typically advanced feature, and their use isn't very, it's not that creating a generic method or a generic type is doesn't happen. It does happen quite frequently, but the typical instances where you would use them would be difficult to explain, you know, with only an hour left of class, would be very difficult to explain. Typically, I do want to point out, though, that I use generics quite frequently in terms of type safety, and that's what they're mainly used for. It's generally, I use generics frequently, yes, but I typically don't necessarily use them to express things that I wouldn't be able to do without generics. I use them to express the intent of things and to express and to prevent people from abusing my classes or passing in things that shouldn't be passed into classes. So I primarily use them as a gatekeeper for type safety, but they're also useful for things that wouldn't be possible otherwise. Quick question. Can you use a generic type of a class and a method in that class? Quick question. Can you use a generic type of a class inside the method of that class? No. You actually can't. So let's go ahead and talk about a generic type. I'm going to go ahead and write a class called stuff, and it's going to be generic. So what is stuff? Stuff is a class that has one generic parameter. The generic parameter I have is named t. Now, that's not necessarily the only name you can use for generic parameters. I do want to point out, though, that there's a very common naming convention in the .NET world to either use t followed by t1, t or t2, t3, and so on, or maybe t1, t2, t3. And then sometimes if you want to give your generic parameters more semantic value, you could always do something like t pi. I don't know.
T flavor. T flavor.
Yeah, T flavor or whatever. So again, it's not that you can name these whatever you want, but at least if you want to give them a specific name, prefix it with the letter T. If you don't want to give it a specific name and it only has one parameter, use T. If you don't want to give it a specific name and you want to have multiple parameters, use T1, T2, T3, T4.
A good example would be a dictionary.
Right, what the dictionary has a T key and a T value.
Yeah.
Okay, so what we have right here is a class called Stuff that takes in a generic parameter called T-key, which means I could write a method inside this class that's written in terms of this generic parameter. I can use this generic parameter anytime that I could use a type. So for example, I can say public void method and I can take in a T-key. So what I've in effect done is I've created a generic type that takes in one generic parameter that has one method that, as a parameter to that method, takes in the generic parameter. So if I go ahead and instantiate my stuff, and invoke method, notice the signature of the method takes in an integer. I can't pass in a string, but if I change this integer to a string, I can now pass in a string. So it's enforcing a level of type safety. So any questions so far? I mean, so a few important things to note. First of all, we cannot instantiate a stuff without providing in a generic parameter. This syntax is only valid in one place in the C# programming language. There's only one place that you can use this syntax, and that is with the type of operator. The type of...
Presumably this is what you were getting at for when you were talking about how you use it in terms of limiting your types.
Right, you can't, well, yeah, you can't use it in any other situation other than the type of operator anywhere. So, yes, we are forced to, because stuff takes in one generic parameter, we must provide that generic parameter. We cannot represent that, the open type in any context other than type of operator. So keep that in mind. I know people are... You what?
Can you represent the closed type in the type of? Do you have to use
yes.
the open type with the type of?
Yes, you can say stuff event, because these are different types. Yeah. This is a different type than that, than this, and so on. What I could do is use reflection to construct a generic type at runtime. So I could say var type equals type of stuff, and I can say make generic type and then pass in type of int, which returns the reflection type into my type local variable. That's the type of the closed type being applied with an open type for the type parameters. Stuff and things. That stuff isn't necessarily important. We are going to be talking about reflection. I just wanted to point that out. I just wanted to the only thing that you need to get away from this is that you cannot use this syntax except for one instance in the entire C# specification.
And if that wasn't var there, that would be that would be type as well. Anyway.
Okay, so yeah, and then that actually brings up, someone asked earlier, can you use the generic type of something inside of methods of that generic type? The answer is no. I cannot say stuff. I cannot say var ble equals new stuff. And the reason I can't do that is because, well, like I just said, this syntax is not valid anywhere. Does anybody know how I could make line 13 valid? And other than segfault, of course. Or Jim, because I think Jim would probably...
Yes, he seems to know these things as well.
Right. We can instantiate, we can use the this inside of the methods. We cannot use the closed type or the open type, but we can close the type by using a generic parameter. And passing around generic parameters is a very important thing to be able to understand. Notice how we're passing in the generic parameter into this constructor. And ultimately, so if we have a stuff of string, ble is a stuff of string. If we have a stuff of int, ble is a stuff of int, and so on.
Essentially, if you wanted method always to give you back a stuff of int, then you would have a stuff of int there. But this way, you'll get back whatever the type of stuff is.
Yeah, when it's applied to the generic parameter that you applied to the first type. It's like a chain. Okay, so can you make a list of stuff of ints? Sure. In fact, I can make a list of t keys if I wanted to. I can say var. I can go ahead and say, if I wanted to, private read-only list of t keys, and then I'm going to go ahead and instantiate it. And I can go ahead and say keys.add key. Now this is a slightly more complicated example because we're handing off our generic parameter to another class that accepts a generic parameter, and then we're invoking methods on that object that only accept things that are of the type of the generic parameter that happen to be correlated between the parameter on method and the parameter on stuff. So we're threading through these generic parameters into other generic types, and we can do that. Things get very, very complicated. You can go down the rabbit hole very, 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 very far with generics and get to the point that you will have no idea if, this code should even compile or not, but maybe it does, and then the behavior would be ridiculously undefined. Well, it wouldn't be undefined. But this stuff really messes with your head once you go dig down deep. Do you want me to... Segfault just brought up a great idea. I'm not even going to invoke that method because I have no idea how to instantiate one of those right now. So now if I look at stuff if I look at stuff.tkeys or underscore keys right here, after being constructed on line 28, the type of this field is going to be list of stuff of stuff of int. Okay, so
it's at this point that I start bringing out the variables. Already, if I'm constructing this stuff, that's a great joy of ReSharper.
Yeah.
A load of variables that you then just inline them all and go, look what I made. That's where I got my 297 character line of code from the other day.
But yeah, even this example though is completely pointless. There is no. I'm not trying to express anything right here other than the syntax itself, because actually using generics to do some awesome stuff, that's going to be when we bring everything together. But you have to understand the syntax first.
Have you got get them to do something? Make them work. Have you got an example?
I have no idea. The problem is that this stuff is so generic.
Kind of is, isn't it?
The homework though is going to be very fun. I think you'll like the homework too, Gavin.
Oh yeah, Segfault's ideas though is quite good.
Make a generic linked list.
Make a generic linked list. That's a great idea.
There actually already is a generic linked list in C#, but I don't think we have time enough for that.
Well, we're coming up on the hour, and we really should see if we can get people doing something. Should be fairly straight. It only has to be a one-way one, really.
Well, how about this? Make a class stub for a generic linked list. Methods must be specified but not implemented. That supports adding an item, removing an item, and getting the count of items and getting an item at a specified index, which isn't typically how you should do a linked list. You should always do an enumeration operation, but still.
Cool.
But we did have a few more questions, though. So line 21 would make the generics what it is, and you can't later change it from int to string once you declare it as an int. Oh, right. Once I apply these generic parameters to stuff, I'm going to make this sane again. Once I apply these this generic parameter to stuff, this object will always be typed to a stuff event, but that doesn't necessarily mean I can't do another local variable and instantiate it as a stuff of float.
In exactly the same way that you can have different types of list.
Right. You can't change the type of the list after you've instantiated, but you can always make another object that has a different type. Okay, cool. So I'm going to go ahead and pause. See if you can work out a basic method stub for a generic linked list. You're gonna also want to include the node structure. Okay, so I'm going to go ahead and pause the video. All right, hey everyone. So let's go ahead and implement this. So what we're going to start off with is a class. I'm going to go ahead and what I'm going to do is I'm going to take off my using systems collections generic because there is another class called linked list in that namespace and I don't want any collisions. Why can't I type anymore?
You need a new keyboard.
I need new hands. All right. So that was basically what I was going for. And I'm getting an error, get int not all codes.
Return.
Okay. Oh, right. Well, of course, I'm going to need a reference to the first node. So private node first.
Now, default of T, is that on your list of things to talk about?
Yep. Okay, so this is the implementation that I was going for, because basically what it does is it just shows people how to create a class with a generic parameter, use that as fields within nested types. That's one of the most important features of generics. We can use the T parameter inside the class node, and here's why. The only way to access, let's say I had a class like this. The only way to access inner is by doing outer.inner. That's the only way to access that type. Now, when we're inside of outer, we can just reference inner directly, but that's because the outer dot is implied. So every time we reference a nested class, we are always accessing it through the parent class. So that's why we can never access node directly. Now you notice I do it here directly, but that's because this is just shorthand for what really happens, which is going to be linked list of T dot node. And by doing that, that's how we, in a roundabout way, supply this parameter to the node type without having to make node an actually generic type.
And another thing would be if you tried to put node outside of linked list, you'd have all sorts of problems.
Right.
Aside from any linked list problems, but how would you work out what T is?
Yep. So node has to be a nested type here. Alternatively, we could have node be an external type, but then we would have to have node provide a generic parameter to it to supply the value for T.
And then you'd have to do validation checking to make sure that it all linked together correctly.
No.
Which would kind of defeat the point of using the generics. It'd be easier just to code up separate.
then I also wanted to show people how to, or have people think about accepting parameters of generic types and returning values of generic types. But we did get a lot of questions. One of the questions was, this isn't actually related to generics at all, but I wanted to point this out. People were trying to do this. That's not going to work. The reason it's not going to work is structures have the ability to be, now remember, as I said this before, structures are value types. Value types are not necessarily going to be always on the stack. They may be on the heap as well. However, they have the opportunity to be placed on the stack. Unlike classes, which can never be on the stack, they have to be on the heap because of the way that they are. Structures can be placed on the stack if they wanted to. So one of the constraints you have with structures is that you cannot have a structure field of the same type of that structure. Because if you flattened out this structure in memory, this on line 21 is not an object reference.
What does that error message say again?
The error message says
struct
member of type node causes a cycle in the struct layout. That's because this isn't an object reference. This is a piece of data. If we tried to if we tried to collapse this node onto the stack or onto the heap, what we would get is, or onto the stack, we would get a infinite loop. And remember, value types cannot be set to null. However, we will be also talking about value types in more detail later. So nodes must be classes. Okay, so there's a few other interesting things that people were asking about. One of them was, why can't I do this? Or, sorry, why can't I do, let's say in my ad, I wanted to, I think Segfault's already answering this question in the chat, but let's say I wanted to make sure the item was never null. If I said item equals null, throw new argument exception, can anybody other than Segfault tell me why why this would be an issue? Actually, it's going to work, but it shouldn't work. Actually, I know why it's working. I believe it was ReSharper that threw me that warning then, not Visual Studio.
Yeah, I was going to say what Marvin did.
Actually, I have a better example. What about add? If I did this, var node equals new node, and I did node dot, oh, hold on. I have to make these guys public. If I did node dot value equals null, that's a compiler error. As well as I can't return null in my get method. And there's a very specific reason why I can't do that. It's because if we pass in a value type into the generic parameter of our linked list, value types cannot be null, meaning line 31 is an error because, well, value types cannot be null. You can't set int to null.
Are you angling towards talking about attributes, or are you not?
I was going to quickly talk about constraints for a second. But what you do in this case instead is you use the default operator. The default operator takes in a type parameter, just like the type of operator, and it'll do one of two things. If the type passed into default is a reference type, it'll return null. If it's a value type, it'll return an appropriate default construction of that value type. You can indeed do nullable t. So if I wanted my nodes to have nullable t in them, I could do that, in which case I could set these to null. Oh, right. Actually, the opposite problem is the case here. I just realized that.
Line 28.
Well, line 20 is now the opposite problem. You can't have a nullable type of a reference type, meaning T may be a reference type, And if you pass in a reference type as into T and you try to get a nullable out of it, you'll get an error because you can't have a nullable type in as a parameter to the, or a reference type as a parameter to the nullable type. So this is the opposite, where you would need T to be a value type and a value type only.
I assume the reason you haven't got any try catches in is purely just because this is an example.
Well, I don't see where I would need any
This
try
is
catches.
This is example code. Well, as opposed to doing your when you had the if is null check in there.
Oh right, yeah. I'm not. This isn't about exception handling. Okay, so one last thing. What if we did want to make sure that, let's talk really quickly about generic constraints. I'm not going to go very much into detail with generic constraints because generic constraints come up once you start doing a lot more complicated things with generics than what we're doing right here. It's good to know what they are. It's good to know what the syntax looks like so you can refer to documentation, but we're not going to be going into them in very much detail. A generic constraint is a way to constrain a generic type parameter to be something. So for example, if I really wanted to be able to set my values to null and return null, I would have to constrain the T parameter to be a class or a reference type. And to do that, we simply do where T is class. What that does is that means that I cannot pass in a non-reference type into this parameter, which ensures that line 31 and line 40 will always be correct. What if we wanted the opposite? Well, we could say T is structure. That means that T is now always going to have to be a value type. So for example, if I put this back into a class and I try to instantiate a linked list and pass in an int, I'll get a compiler error because it says the type int must be a reference type in order to use as parameter T in the generic type or method, blah, blah, blah. But
if you pass in a string.
Yes, I could pass in a string because a string is a reference type and can be set to null. There's another interesting thing you can do. There's two more interesting things you can do with generic type parameters. Let's say that I wanted the generic type parameter to be anything that implements an interface called IMyInterface, and IMyInterface has a void method on it. Notice how, I need to back up really quickly. Notice how my node.value is typed to T. Everybody is aware that node.value is typed to T. That's the type of that, and T is provided as a generic parameter. If I do value dot, notice how I only can invoke the four methods that are provided to us by the object class. Unlike C++, C# cannot invoke any methods on a generic parameter that is not in some way guaranteed to exist. That's not the case for C++. In C++, you can accept a generic type, a parameter of a generic type, and you can invoke any arbitrary code you want on it. In fact, in C++, other than syntactic validation, there is no other sort of validation on templated code in C++. Meaning that if you invoke a method on a generic parameter, and let's say we invoke a method called foo, C++ would let this class compile. But then if I tried to create or construct a object of this generic type, and I pass in a type that doesn't have the method foo on it, then we'll get an error. One of the slightly frustrating things about it.
So presumably here, you can on line 20 replace class with IMyInterface.
Yep.
Or not.
So what we can do instead with generic type parameters, if we really want to enforce that every type parameter that's specified for this class inherits from or implements something, we can. I can say IMyInterface. And if I do IMyInterface, we are constraining this type parameter to be anything that implements IMyInterface, which means we can guarantee that by doing value dot, we have a method called method, because we know that any generic parameter passed in is going to implement IMyInterface, and then it's safe to call method on it.
And as a quick aside, because this will cause confusion later in this lesson otherwise, if you get the two confused, this is where with lowercase w.
Yes.
On line 20.
Why does line 44 now fail? Line 44 still fails because you can implement interfaces with structures. Structures can implement interfaces. If I wanted to make line 44 work, as well as constrain it to an interface, I could say IMyInterface followed by a comma followed by class. Or sorry, class followed by IMyInterface. I always forget the order of those. And so you notice I get an error now. Type string cannot be used because string doesn't implement IMyInterface.
Is that in the same way as if you're inheriting and implementing at the same time? You have to do them you can have one inheritance followed by as many interfaces you want. Is that similar with this? You can have one class, or can you have many classes on line 20?
You could only have one class. Otherwise, it would be impossible.
I mean, obviously, having class again would be pointless, but could you have class, comma, enum?
Oh, well, you couldn't do something like this, because that would be a contradiction.
What about
enum actually is...
What are enums?
Enum's a funny thing. Enums are always value objects. There is no generic type constraint for enums, even though there very well could be. There is none in the C# language for some reason. I'm sure I read a blog post that Eric Lippert made at some point over the last couple of years that said why this feature would be pointless to implement and blah, 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 why the C#
Well, you've already got enum parsing.
But
I suppose because you've got enum parsing stuff, you can just do it with ints instead.
Well, yeah, and what you would want to do for an enum is you would use struct. What if my class T1, T2, what's the syntax add constraints for each generic type? This. So you would do where, and then you would do another where. Okay, the final thing about, hold on. You have to use interfaces, not actual class implementations. So something like class, my class, and then doing, instead of this interface, we can force my class. That's not going to work. What you could do, though, is if you just specified my class itself, you could only have one class constraint. So you would take off the class constraint and add the specific class constraint. Then that would work. But this would constrain T to only any other classes that inherit directly or indirectly from my class. If you have an instance called X, can you say new linked list of type of X? No. Well, yes and no. The answer is, let's say I have an object called myInt and it's an int. The question was, could I do this? There's two reasons why you can't do this. The first reason why you can't do this is you cannot specify anything other than a type into the type of operator. The type of operator requires it's a type, not a object instance. The second reason you can't do this, so let's say we did this instead, myInt.getType. If we did this, this is an error because that's not compile time code. Generics, using the syntax of instantiating a generic type, it always must be compile time code. It cannot be runtime code. But what we could do, let's go ahead and remove the second generic type parameter for clarity. What we could do is we could say type of linked list closed, make generic type myInt.getType and wrap this in an activator .create instance.
I think we were doing reflection this week.
We are not going to have a lot of time to talk about reflection, but here's an instance of using the reflection. This will compile, but this will fail at runtime. The reason it's going to fail at runtime is I'm not going to be able to make a generic type of int because it violates the constraint of type T. But notice that happens at runtime rather than compile time, which is a huge distinction.
Which seems worse to me. But anyway, we're getting way off subject here with all this reflection stuff.
What if you want linked list to implement an interface, not T? I don't understand the question. Linked list could very much implement an interface. I could say, let's say linked list implements IEnumerable of int. Or how about IEnumerable of T? Now I'm getting these mixed up, aren't I?
Oh, I see what he means. He means, what if you want linked list and not T to implement an interface? What if you want the linked list to implement an interface, but
well,
not?
you do this. You would have the interface definition up here, and then you would have your generic constraints after. Notice something interesting about this example. I'm implementing a generic interface. IEnumerable T is a generic interface, and I'm inheriting it, and I'm passing in, I'm threading through T into IEnumerable of T.
Presumably, actually no, that wouldn't cause a problem if it was an IEnumerable of foo, because it would still just be an implementation. It would be a constraint. It wouldn't matter if you weren't threading that T through. Is what I'm getting at.
Yeah, the constraint still applies.
Yeah.
Okay, so last thing about... I'm going to go ahead and do two more things really quickly. I'm going to nuke all of this code for now. And then I'm going to show an important thing that we are going to be doing for the rest of the class today. And those are generic methods. A method can be generic just as a type can be generic. And a method being generic is very similar to a type being generic. So let's say I had static void let's do some foreshadowing. Filter of T, IEnumerable of T, source, func, T, bool, predicate. Okay, so I'm starting to bring everything together here. I have a method that is generic. We know it's generic because of the angle brackets being applied there. And it accepts an IEnumerable of T. We're threading the generic parameter that's passed into the filter method into the generic parameter for the IEnumerable type. And then we're doing the same thing with our delegate. Our delegate, every delegate that we can pass in here must take in a T and return a Boolean. So here's an example of a generic method. Actually, I do want to back up one more step from this. So there's your foreshadowing. I'm going to stick that on a notepad somewhere else and back up again. I'm sorry I'm being confusing. Because I just wanted to throw, I'm trying to throw out an aside right here. Let's say we wanted the hey method to return a new instantiation of T. This is not going to work. It's not going to work because we cannot instantiate generic type parameters because we do not know the layout of their constructors. But we can constrain those. So I can say where T new.
You kind of skipped very quickly over that line, which I think is quite important, when you said we cannot instantiate new T's because... What did you say about the constructors?
Because we do not know their constructor layout. We do because a type, unless it's a value type, a type is not required to have a parameterless constructor. Meaning, which constructor could it choose for everything that you can pass into T?
Yeah, I just wanted to, because you zoomed through that sentence, I just wanted to rub it in.
But we can constrain our type parameter to force it to have a parameterless constructor, which is what the new constraint does. However, the new constraint cannot be used for anything other than parameterless constructors. I want to point that out really quickly here. I cannot say new int if I wanted to force T to have a constructor that took in an int. This would be an error. I want to point out that this... You what?
Never mind.
I want to point out that this constraint isn't that useful. I don't use it very often, but I wanted to show you guys that it existed. If I wanted to use this, let's say I have a class called whoa, and I wanted to use this method, I could say item equals hey of whoa. So notice how I'm passing in the generic parameter. I'm applying the generic parameter to the generic method and invoking it, and it'll return a new instantiation of the class whoa, because that's how this works. And we can pass in whoa because it does have a parameterless constructor. However, if instead of having the compiler generate the default constructor, if I instead added another constructor, notice how this now fails, because it fails the generic type constraint. Okay.
Cool.
Is there any bit of this syntax that's confusing to people? The syntax covers returning generic parameters, accepting generic parameters, and constraining generic parameters. Because that's going to be, again, we're pretty much going to be building off of all of this for the rest of the class here today. And getting into something that's actually really awesome. Okay, so let me go ahead and bring back that example I had up previously, because that's going to be a little bit more complex, but it's actually a useful example of code. Okay, so what this code does here is we have now constructed a generic method called filter, and it's incredibly important for two reasons. First of all, it can take in any IEnumerable of any type. Then the method that we can pass into the delegate here on line 16, the delegate I named predicate, or the parameter I named predicate, will be constrained to accepting whatever the IEnumerable we passed in's type and returning a Boolean. So if I wanted to use this method, I could go and say var list equals new list of int 1.
Pull out the Fibonacci numbers, just for a change, just to make you think a bit. No, I mean just a normal list of ints.
Oh, pull out.
And then filter for the filter for the.
I wouldn't be able to do that in a short amount of time. I mean, is there
some of the preceding two?
Oh,
and if there isn't any preceding one.
That actually would complicate the example a little bit, because it would have to keep track of the preceding two. The way that this works, the beautiful thing about this is that it works very well when you don't need to keep track of other things, which is sort of an...
All right, just do an odd and even then.
So now I can go ahead and say odd equals filter of int, pass in list, and then pass in I goes into I mod 2 does not equal 0. And I can do even. I'm going to do something crazy here.
He's crazy.
Indeed.
But it's just two different syntaxes for the same thing, yes?
Yeah.
And I think I may have made up the word syntaxes, but it should be, right.
Okay, so now when I run this code, we get our odd and even numbers. Okay, so when I invoke this code, when I write this code, so many things are happening behind the scenes. So many things are being done for us in a way that's type safe. See, the great thing about C# is that it's a static language. Now, I know a lot of people would disagree with that. A lot of people like dynamic languages, and they certainly do have their place. But one of the great things about static languages is you get a lot of benefits, especially in regards to tooling, in regards to being able to have the compiler be thought of as basically your first unit test. Whereas with dynamic languages, things get very muddy very quickly unless you're very diligent. And the great thing about C#, though, is that while it is a static language, by combining generics, interfaces, extension methods, lambdas, and generic type inference, we can get statically typed code that is very, very succinct. So what I have right here is two invocations of my filter method. One that specifies my generic parameter explicitly and one that does not. One of the great things about generics is that they are very good at, that C# type engine is very good at inferring your generic parameters. Which means that when this happens, the signature of filter looks like this. Signature filter looks like IEnumerable of int, IEnumerable of int source, func int bool predicate. By specifying that generic parameter of int, the signature of list changes to magically accept everything that I want it to. So notice how this delegate right here, func of int and bool predicate, actually changes to a statically typed integer. Which means if I hover over I in this lambda, you notice that it says parameter int I, because the C# compiler is able to know what's going on. However, in this case, the thing is if all of the generic parameters are specified in the somewhere in the argument list, the C# compiler will be able to infer the generic parameters as best as possible. So when I do even equals filter of list, because list is being passed into source, and because source is an IEnumerable of t, and list is an IEnumerable of int, it matches up an IEnumerable. Well, it actually matches up a list int into an IEnumerable of t. And what happens is the C# compiler knows that list implements IEnumerable of int, so it does this. It converts list into an IEnumerable of int, and then it needs to convert that into an IEnumerable of t. Well, what's the only way that we can make this conversion work? That's by finding the t parameter, extracting it, and realizing that t equals int. And by extracting t equals int, it now knows that predicate is a func of int and bool. So when you start talking about generic types, things get very meta. And that's one of the sad things about working with them. A lot of the working with generic types is going to be a lot of intuition that you gain over by using them. But there is a very logical way that you can follow through the steps that the C# compiler goes through to determine if your code is valid. However, let's back up and let's go ahead and make a person class. I like people classes. So I'm going to go and instantiate a list of people. Var people equals new list of people, or a list of person. And I'm going to go ahead and initialize it to a new person, first name, no. I'm just going to make a constructor. I tried.
Somebody said, can you full screen?
You what?
Somebody said, can you go full screen, please?
Yep.
And probably kick up your font one, maybe.
Okay, so I'm going to instantiate a list of people, P1, P2, and then let's throw in a few more people and stuff. Let's do A1.
Sanders said, Alt insert enter. He doesn't have resharper on for the videos. It's banned.
Well, fine. I'll do, how about Aaron, Andrew, and Nelson. Okay, so what if I wanted to reuse my filter method, which again is lines 43 through 48. Actually, let's back up. Let's say I don't want to use my filter method. I want to grab out every single person whose name starts, or his first name starts with an A. So I can go ahead and, this is how you typically do it. You'd say var people starting with A equals new list of person, and then you do for each var person in people, you do if person dot first name dot length is greater than 0 and person first name 0 equals A. Actually, I want to do dot equals A, and then, oh, you're not going to let me do that, are you? Fine. Too lower. Oh, I hate characters.
Funnily enough, I was having this issue yesterday.
Okay, I don't really care about how this is actually not proper right now. I'm just trying to show the example. People starting with A dot add person. Okay, that's a lot of code to write to find all the people whose name are starting with A. So how would I be able to use my filter method? In fact, actually, you know what? It's time for another break, and I want people to write a method invocation of filter of T that returns an IEnumerable T of all people whose name starts with the ladder. Hey. Okay. I'm going to go ahead and take all of this code and copy it into a notepad window so that we can fit everything on the same screen. All right, now I'm going to go ahead and say reset. Everybody who wants to tackle this, I highly suggest to tackle this. Be sure, if you want to write this on your own computer, copy out the filter method, copy out the person class, and copy out the people list. You don't need this to do what I'm trying to ask you guys to do. So go ahead and hit participate if you want to be adventurous and awesome. And
you can pause the video.
Yeah. And then I'm going to pause pause the people. I'm going to go ahead and pause the people. Goodbye, future people. And we're back. So, yeah, how to actually go about doing this, to rewrite this nasty bit of code with something that would be a lot more appropriate, it would look like this. So what we have here is an invocation of the filter method that allows us to filter out people based off their name.
Have you got time to do like a 30-second digression into the comparison types?
No, because it gets complicated. Okay. Well, I can do a 10-second one.
I want to ask you about them at some point in that case, because I need to know some stuff.
This is string comparison current culture ignore k should always be used rather than .to lower. I actually forgot about the starts with method when I wrote this, but yeah. Okay, so yeah. What we have here is an invocation. So we can replace all this nasty code with this nice and clean code. And what we have going on here is we have a lot of really, really complicated things that we've been talking about in pretty much in isolation over the last 2 weeks now. We have an example of a generic method. We have an example of a delegate that's actually generic delegate. We have an example of using the IEnumerable of T, which again was covered later on in the 102 class, as well as use of the iterator blocks. I want to point out something, though. Someone said something interesting where they put a breakpoint in here. If I hit F5, what is the first line that's going to be hit? Not segfault. because I know you know the answer. There were a few questions earlier that I didn't know that you knew the answer, but okay.
Will be the constructor of string, surely.
So let's go ahead and hit F5, and look, we hit 28. Whoa, what's going on here? Let's step through this line by line. So I'm going to go ahead and hit F5, hit F11 to step in. Notice how we get our behavior that we expect. We instantiate all of the people, we instantiate the list. But now on line 26, when I hit F11, you'll notice execution does not jump into line 33. That's because what's returned on the method of line 31 is not a bunch of values, but instead is an instantiation of an iterator object that represents the operation that I have expressed in code. So this is an iterator block. And I talked about this in the last class of 102, but what it means is that because of the existence of a yield return statement, as well as the fact that this method returns an IEnumerable, that's what makes this an iterator block. And iterator blocks are treated by the C# compiler in a very complex way. The C# compiler actually takes this method and turns it into a class. And that class has a state machine. And that state machine allows the execution of this method to defer or to yield back to the caller. Which means that the code here on line 33 never gets executed until we actually use the result of people2. So if I were to add a for each loop right here, for each var person in people2, now you'll see that when line 28 is hit, we're in the for each loop, and that when I hit people2 and hit F11 one more time, or two more times, now we jump into the filter method, and now we're in the filter method. And then when I hit the predicate, notice how execution jumps all the way back to line 26 for our lambda. But our lambda actually has a parameter filled in, p, which represents the current person we're looking at. And so now you'll notice, just notice how the execution flows. There's one important aspect of deferred execution that people often don't realize. Okay, what's the output of this program?
Oh, I see what you're getting at. I was miles away there for a minute.
Right, now we're going to have 3 results. So then if I did this again, and so here's the console write line. Now if I run this code again, notice how the first iteration has 3 results and the second iteration has 4. This is an example of deferred execution. The people2 is an object. It's not just a list of things. What it represents is a computation. And that computation is tied to or chained to this original list, meaning that every time I for each over my computation, it's going to use the latest bit of information of our list, which is the original source of the data. What if you added a person to people2? Ooh, you can't add a person to people2. See, people2 is an IEnumerable. Let me go ahead and get rid of LINQ for a second. People2 is an IEnumerable. Notice how line 44 we return an IEnumerable. People2 is not a list.
If you, on lines 24 and 25, explicitly declare your types.
The first type is a list of person. The second type is an IEnumerable of person. That's because the IEnumerable represents the iterator block. It does not in any way represent the original data structure. IEnumerables are read-only. You can only read from them. And that's good because IEnumerables can be used to represent anything, from arrays to lists to dictionaries to hash sets to the Fibonacci sequence to a range of numbers to any sort of computation to an infinite listing of numbers.
Basically anything that you can enumerate.
Yeah, anything that you can enumerate, meaning anything that you can go on, okay, I have this value, give me the next value. Okay, I have the next value, give me the next value. Okay, I have the next value. Anything that can fit into that schema.
And it doesn't matter how convoluted the calculation is to provide the next value.
Right.
You could literally be doing all sorts of calls to other namespaces, classes,
Databases.
Provided that it, at the end of the day, returns essentially something, the next one of the same type. Yeah, it's enumerable. You can enumerate through it.
Yep.
Take each number in turn.
And that means that while we can use enumerables to represent collections, we can also use enumerables to represent sequences, even infinite sequences. Okay, so how lost is everybody at this point?
This is the cool thing about reading all this ridiculous stuff that I've been reading recently that I don't quite understand, which is that I then come into this class and go, actually, this is a cakewalk in comparison. Whereas before, I was kind of going, wow, this is getting tough. Now I'm looking at this going, oh, this is a lot, yeah, I'm enjoying this more.
All right, well, apparently we left somebody in the woods. Is there anything in particular that's becoming very confusing at this point?
I think moss grows on the north side of trees in the northern hemisphere. Or is it the south? No, it's...
Okay. So, let's quickly recap. Actually, let's do another cool thing.
Well, I've got an example that might be a useful one because it's quite a common thing.
Okay, so what's up with this method? This is a generic method that returns an IEnumerable, but notice how I have two parameters. I have a t source and t result. The point of this method is to be able to convert from any source enumerable into any result enumerable by using what's called a projection. And the projection is the term for a function that maps between two types. Well, it could map between the same type, but just with different values, but still. So what I have here is a method. Again, this method signature looks incredibly terrifying, I imagine. But let's go ahead and break it down. The first thing that you should read when reading a generic method is the modifiers for the method. In this case, this is a static method. And then read the name. Skip over the return type for now. Read the name, because the name is going to not only provide the name of the method, but also the generic parameters. So we notice that the name of this method is map, and it has two parameters, t source and t result. So now let's jump into the return type. So notice how I am jumping around a little bit, but this is necessary for reading generic methods. If you now jump back over and look at the return type is an IEnumerable of t result. I mean, it doesn't matter what this type is, or as long as it's an IEnumerable of something. Now we jump into the parameter list. The parameter list has two parameters. The first one is an IEnumerable of t source called source. This is where we're going to be pulling the data from initially. This can be any IEnumerable. It could be an IEnumerable that is fed in from another iterator block, such as filter. It could be an IEnumerable that's fed in from a database. It could be an IEnumerable that's from a collection like a list. And then the second parameter is a func of tSource and tResult named projection. So that means that this func, this delegate, takes in a tSource as a parameter and returns a tResult, and we name that func projection. So then inside the body of the method is very straightforward. We loop over every item in the source, and we yield the item that we extracted from the source applied with the projection. We apply the projection with the item.
And essentially what you've got there is, in between lines 42 to 46, is a graphing program, all bar the actual drawing. You're taking X and mapping it to Y.
Yep. And yeah, that's definitely one of the uses for it, especially more...
because if you make projection be, X squared, or you make, source squared equals result, or you do whatever function you like, can be put into there, and that's the heart of it. In fact, that would make a good homework, just for future reference.
I do have homework already figured out, but yeah, and it's actually going to be partially about that. But the great thing about it is that although it does have like inherent correlations to mathematics, because we're in C# land, we can do fun stuff with this. For example, let's say I wanted to... Okay, so I've already filtered out all of the people that have a first name that starts with A. Let's say I wanted to grab out the first name for all of those people. And I guess Segfault apparently already beat me to writing out this code. What I can do is I can say var first names, and I'm going to actually do IEnumerable of string first names equals map person to string people2 as the source enumerable, and then p goes into p.firstname as the projection. Now this could be rewritten like this, if I wanted to. Note that these two method invocations are perfectly equivalent, per the rules of implicit typing and generic type inference. Okay, so now I can go ahead and loop over all of my first names. And run this code and see I get Aaron and Andrew. So let's go ahead and let's run through this code. If I hit F11, notice the first thing we go into is the map. Notice how the map, when it enumerated the source, it jumped into filter. And now filter, when it runs, it's going to invoke the lambda that I specified here on line 25. And then, if that lambda returns true, which in this case it does, it's going to return the item back into map. So now map has this item right here. A person, Aaron P2. It got the first item because the first item matched the predicate that we passed into filter. And now we yield the projection of the item back to the caller. The projection of the item is simply this very straightforward lambda right here, which extracts the first name. After we yield that, we jump all the way back into the for each loop. So notice how execution jumps from the for each loop. Well, let me do one more iteration. I already messed it up. Execution jumps from the for each loop to the for each loop in the map, to the for each loop in the filter, to the predicate that decides if the item should be returned or not. And then if it doesn't want to get returned, it goes back into the map. Now the map is empty because the filter has decided there's no more items in the collection. And now we jump into this, and this is empty. And we jump into the read key.
Cool. But Nelson, surely if these sorts of things are so common to do, having to write them out and make them ourselves is a bit of a pain, isn't it?
Well, right. This is the foundation of LINQ.
Yay.
LINQ is a lot of things.
Yay.
It's very difficult to describe LINQ as just one thing. It's a collection of a variety of other techniques.
Boom.
The components of LINQ are, first of all, the extension methods on the IEnumerable of type T. Remember, does everybody remember about extension methods? For example, let's say I wanted to turn both of these methods into extension methods on IEnumerable. Let's go ahead and do that real fast. I'm going to cut these out of the program class, and I'm going to create a class above it called Enumerable Extensions. And I'm going to make it static. And then these two methods I'm going to make public, of course, because now they're outside of the program class. I'm going to go ahead and turn these into extension methods. So I'm going to say this IEnumerable T source. And this, actually, just to follow through with my typical naming. Okay, so now we've turned our map method and our filter method into extension methods. What we can do now is, instead of writing this code, I'm not going to lose this code, I'm going to go ahead and dump it somewhere on my screen. Let's go ahead and write our first names in terms of extension method. So I can say first names equals people.filter. First name starts with a string comparison, ignore case, dot map, P goes into P for first name. Let's go ahead and break this out into multiple lines to make it clear. What I've just done is I've used these two extension methods that I applied to the IEnumerable of T type, and I've made them chainable. So now our code is becoming a lot more succinct and straightforward. The same things are happening, but we're just doing it in a way that is a lot more readable. How's everybody feeling at this point?
Mostly shiny. Partially dulled.
Okay, remember that these are now extension methods, and I can invoke them on IEnumerables. Remember that list implements IEnumerable, which means any extension method I apply to the IEnumerable type is available on the list type. The same is going to be true for arrays. Arrays are also IEnumerables, as well as dictionaries and so on. Another thing that's an IEnumerable is this. Because these methods return IEnumerables, we can chain method invocations, which is what we have going right here. Looks like jQuery. Yeah, LINQ can be very similar to jQuery in some instances. In fact, they borrow a lot of the same ideas. Okay, so what is LINQ again? A LINQ is a variety of things. The first thing LINQ is a bunch of extension methods on IEnumerable. In fact, these two methods are provided to us by LINQ already. Map is called select and filter is called where. Now, I'm very disappointed with some of the naming that they used for IEnumerables, because instead of using the functional style naming conventions, which map and filter are, they used SQL style naming conventions, so that people who are used to SQL, which is a variety of the target audience of C#, or a majority of the target audience of C#, to make things clear. So in LINQ, map is select and filter is where.
Well, and it's weird because some of the, I don't know, it's 6 one and half a dozen of the other, because, like, for instance, map is a better name than select, but I think where is better than filter. So you're never going to please everyone.
Well, at least they were consistent in making it consistently like SQL rather than,
Squirrel.
Okay, so so the first aspect of LINQ is it's a bunch of extension methods on IEnumerable. To use those extension methods, we must import the, you guessed it, using system.link namespace. By adding in the using system.link namespace, every single object that inherits from IEnumerable has been given a lot of functionality. So let's go ahead and look at that functionality. Instead of doing people.filter, what I can do now is do people.where, which has the exact same signature as my filter. Instead of doing where.map, I can now do where.select. All of these methods, or most of these extension methods, are an aspect of LINQ. We have aggregate, all, any, as enumerable, as parallel is actually not part of LINQ, as queryable, average, cast, concat, contains, count, default if empty, distinct, element at or default, except, filter, actually no, that's the one I just defined, first or default, group by, group join, insert, join, last or default, long count, map, max, min, of type, order by descending, reverse, select many, sequence equals, single or default, skip while, sum, take while, to array, to dictionary, to list, to lookup, and union, and where, and zip.
LINQ is pretty much where you're going to look initially for any sort of operation that in some way mutates a bunch of data.
Not necessarily well, performs computations on.
Well,
there's a better way to say it, because LINQ will never touch your original enumerator.
Oh, I suppose, yeah, it returns them, it does a mutation to data.
I'm not aware of a comprehensive list of LINQ methods. Well, actually I am, but it would give away the homework. But you can look in the documentation. Do any IEnumerable dot, anything that you see with this symbol is most likely from LINQ, because these are all extension methods.
Well, simple way, if you just actually remove your LINQ using, I know that'll throw you some errors, but if you remove your LINQ using and then show the tooltip.
Well, yeah, that's going to be pretty anemic. These are just methods that are aspects of list, and then these are just methods that are aspects of IEnumerable, which won't pop up because of compiler error. But yeah.
It's about the scariest thing about LINQ. It's just the fact that once you add it in as you're using, you've got so many options. But generally speaking, you're going to be using a few of them a lot.
Right. Where and select are the two most common. Things like sums, first or defaults. For example, if I wanted to grab the first person whose name starts with an A, I can do first or I can do first. First will return the first thing that's passed in. It'll just return the first item and then return. So you notice that first does not return an IEnumerable, it returns a person. But if first is applied on an empty sequence, it throws an exception. First or default, if provided an empty sequence, will just return the default of T, which is going to be null in this case. Furthermore, you can actually combine first or default and first both have an overload that accepts a predicate. Meaning I can say, instead of writing this where, I can say, give me the first person or null for the persons whose name starts with A.
And funny enough, I was about to ask about that, because generally speaking, is it right to say that generally speaking they all have an overload with a predicate, or nearly all of them have an overload with a predicate?
A lot of the first or default, last and default, and single and default.
Well, where, any...
Yeah, any can take a predicate or not. Count can take a predicate or not. Long count can take a predicate or not. So there's a lot.
Yeah, I mean, it's a vital part of, well, not vital. It's a key indicator of the sort of functionality, the sort of situations in which you use LINQ tend to be of this form where you're going through stuff looking.
Yeah, LINQ.
Whoa, wow! I've had a complete language failure.
LINQ primarily works on IEnumerables. Well, it only works on IEnumerables. So you're always going to be dealing with collections of things. So yeah, we can go over some of the LINQ operators. I'll be going over the LINQ operators during, from here on out. If I use something that hasn't been explained, I'll just explain it on the spot. There's way too much to go over right now, just because this lesson included generics. We could spend, it might not be a bad idea to review LINQ and go over some of the other LINQ operators next week as well, especially for people to get a chance to rewatch this video, because rewatching this video is very important for understanding some of these methods. So I said that LINQ, one aspect of LINQ was the fact that it supported all of these extension methods on IEnumerable, but not just that. This is also LINQ. LINQ is also a language extension to the C# language. What the language extension does is it provides a query-like syntax for expressing these method chain invocations, meaning that this code directly translates into the earlier code that you saw where I chained a where and a select together. So here we have the query syntax of LINQ. There's also a few other things that we can do. You can also order by. So I can say order by p.lastname, for example, and that will invoke the order by method. Whether or not you should use the query syntax is entirely up to you. In some occasions, the query syntax is a lot more readable, and in some cases, the query syntax is a lot more cumbersome. It really depends.
Can I just throw in that I don't know I've ever seen some of those before, which leads me to suspect that you don't use it very much.
I don't really use it very much. There's one really nice thing you can do in query expressions. You can use the let binding. I'm not going to go over the let binding, though. Okay, so yeah, so here's another aspect to LINQ. What does this turn into? This literally gets translated on the first pass of compilation into the invocations of those methods. That is it. So it's just a little bit of syntactic sugar to integrate with LINQ. But that's not all LINQ is. For example, there's a static class provided by LINQ called IEnumerable, and IEnumerable provides a few nice little things. Not only does it provide all of these extension methods for whatever reason.
Aggregate.
I mean, these are where the extension methods are defined in. If you do enumerable dot, you'll get a listing of all of the LINQ methods. But it also has some static methods. For example, one of the nicest static methods out of this is range. So I can say range from 0 to 99. And this will give me an enumerable that represents the range from 0 to 99. And then because it's an enumerable, I can do dot select. Let's say I want to select all the squares of 0 to 99. But I only want the ones that are, I don't know, less than 50.
Squares of odd numbers. Oh.
You know, whatever you want to do, you can continuously chain this. So enumerable has a lot of static methods that we can use. There's also another one called empty. Empty, I'm not going to come up with the use cases for this. I use this quite frequently, but it's kind of bizarre, some of the cases that I have to use it. Empty essentially just returns an empty enumerable of any type you pass in. So if I wanted an empty enumerable of ints, I can do enumerable.empty int. This is much more performant than instantiating a new list event and simply not adding any items to it. There's also stuff like repeat. Repeat allows me to repeat anything. So I can go ahead and say, I want to repeat the string A 20 times. So now I'm going to get 20 A's. And notice that because of the way generic type inference works, it knows that what repeat is returning is an IEnumerable of string because, well, we passed in string as the first parameter.
So you'll end up with 20 strings.
Yes.
You won't end up with one string that's 20 times as long.
Yep.
Just to be clear. And really, you could go on for a good hour or two just literally doing this with each one on LINQ. We could be here a while.
Somebody asked a question. If enumerable.empty int, you can still add items to it, and the answer is no. You may not. You may not add any items to this because it is not an array. Actually, if you dig into the implementation of this method, it actually does use a very, very clever compiler trick to make this extremely performant. It does actually use an array, but it uses an array of 0 elements as the enumerable that it returns. Regardless, take this aspect of your mental model of C# and completely remove it. Enumerables, or add to it, or whichever way. This is very important. Do not think about enumerables as collections. Enumerables you cannot add something to an enumerable. You cannot remove something from an enumerable. You can filter something out of an enumerable. You can create another enumerable that takes all the items from one enumerable and takes all the items from another enumerable and just enumerates over both of them at the same time. Like, for example, if I wanted to combine, I can go ahead and say new 1, 2, 3, 4 and dot concat new 5, 6, 7, 8, 9. Notice how what I'm doing here is I'm returning a new enumerable, but this enumerable is not an array or a mutable thing. It is simply an enumerable that will enumerate this array, and then once it's done enumerating this array, it'll enumerate this array. It's chaining the two arrays together, but it's not actually mutating them. LINQ is entirely non-destructive. There's no way, it is physically impossible for you to in any way mutate the data that an IEnumerable contains, because an IEnumerable can be anything from a computation to a database call to a file to a list.
It's that classic all cats are black problem again. A collection is an IEnumerable, but an IEnumerable might not be a collection.
Right. So there's no way to add things to an enumerable ever.
Around about this point is when you really have to start getting your head around what functionality comes from where in things. And start, it can be, you sort of start, once you start getting more than one, once you get proper composition with more than one interface, you have to, if you lose track of what's coming from where, it can throw you off sometimes. And in this case, it's, the ability to add things is not part of the IEnumerable chunk of functionality, for want of any sensible way of saying it. Help? Yeah,
you have to keep in mind the static types of everything as well as the runtime types of everything. If you are statically referring to a list as an IEnumerable, it is impossible for you to invoke any of the methods on the list, even if at runtime it's still a list. Okay, how does IEnumerable relate to the getEnumerator method? Every IEnumerable has an getEnumerator method. That's in fact enforced by the IEnumerable interface. All the IEnumerable interface is it enforces that what you have is what you're forced to have is a method called getEnumerator. The getEnumerator method is used by the for each loop. So instead of basically when you do this, actually what happens is this. This is what a for each loop actually gets compiled down into. So this for each loop, well, let me go ahead and actually, and then maybe make it a little bit cleaner. This gets translated directly into this. So that's how a for each loop is able to enumerate an enumerable. Because what it does is it asks the enumerable to get its enumerator, and then it continuously invokes the move next method of the enumerator in a while loop. It extracts the variable out of the enumerator.current property, and then it sticks whatever code you placed into the for each loop right into there. And this was actually talked about in the last week of C# 102. Okay. So we have another question.
So see
what?
Exactly what you were about to say.
Yeah. So can you directly query a database using LINQ? That brings us into the last aspect of what LINQ is. Remember, the first aspect of what LINQ is a bunch of static or a bunch of extension methods on the IEnumerable type. The second aspect of what LINQ is a language extension that works with those extension methods. The third aspect to it is a few static methods on the enumerable type that allows you to do things like repeat, empty, and range. The fourth aspect to IEnumerable to LINQ is the IQueryable. The IQueryable is interesting because it's almost exactly like an IEnumerable, and in fact all the same methods on it are of type IEnumerable. So if I go ahead and say var ble equals new 123 dot as queryable, and then I do ble dot.
Does IQueryable actually implement IEnumerable?
Yes. Which means that, so notice that if I do ble dot where, notice what pops up. We have the IEnumerable extensions, but more appropriately, we have the IQueryable extensions. The IQueryable extensions get into some very, very complex language features. Notice how it doesn't take in a func of int and bool. It takes in an expression of type func of type int and bool. LINQ does not define any way that you can access a database directly. LINQ has no ORM tied into it. It doesn't know about databases. It doesn't know about data sets. It doesn't know about ADO.NET. It doesn't know about Hibernate. That being said, IQueryable is an aspect of LINQ that people who write libraries that work with databases can choose to expose. So a person writing in Hibernate, and they've actually done this, expose IQueryables for the types that you can query over. What it does is, this gets really complicated. I don't want to spend too much time talking about it. But essentially, when we pass in a lambda to this, what the C# compiler actually does is it turns this lambda not into a method, but into a piece of data called an expression tree. And then it passes that expression tree into what's called the query provider, which is an aspect of whatever library you're using. By using the asQueryable method, I'm not actually getting access to any query provider that's any more advanced than LINQ itself. The asQueryable method just returns a IQueryable that just does things in memory. But if I...
So var
you what?
On line 41, var is IQueryable.
This is IQueryable event. However, if I got this queryable from a library that supports IQueryable, when I did .where, the C# compiler, because we're passing the lambda into not a delegate, but an expression, the C# compiler actually takes our code and turns it into data, then sends that data to the specific library that's going to handle our database interaction. Then that library is going to parse that expression tree and turn it into a SQL query that it's then going to execute on the SQL server itself. So the answer is yes, you can query things with LINQ. You can query databases with LINQ, but you have to be using a library that knows how to bridge the two things together. LINQ isn't going to magically... LINQ gives you a standardized interface for making strongly typed queries in C#, but it's up to the individual library authors of whatever database library you're using to actually support it. It's a very, very difficult thing to support, to be honest.
Have JetBrains. Is it not there?
I don't think JetBrains has any query providers. Things like NHibernate or Entity Framework or LINQ to SQL, Those are ORMs that do support LINQ providers.
ORM?
ORM, Object Relational Mapper. The ORMs are a category of external libraries that solely exist to map database tables to classes inside of your code.
Okay. Yeah, if this is a tangent, then we probably should
It's something that I wanted to point out because
and put an end to it.
Because it's something that people would hear. People would be like, "Oh, I love LINQ. I can query my database with it." And then people are like, "Sweet. So how do I do that?" Well, the answer is actually a lot more complicated than just saying yes or no. Yes, and Hibernate is one such library. And Hibernate, as of Hibernate 3, there's a LINQ provider built straight into the library. That's very efficient.
So, have you got is that about it for what you wanted to cover in terms of LINQ this week?
Yeah, it's going to be something where if you guys,
because I mean it's huge.
Yeah, it's something that we're going to have to. I'm probably going to dedicate some time next week to talk about more of the LINQ methods because there are quite a few of them that are very important to discuss. But for now, I think I'm done for today. I really encourage people to rewatch the video, play with LINQ on their own computer to see what they can come up with. And as homework, what I want people to do is create a... Let's go ahead and get a notepad up somewhere. I want people to create the following extension methods on IEnumerable of T. We're going to want I'm going to prefix all of these methods with my, and the reason I'm doing that is to differentiate them from the LINQ methods that share similar names. My select takes in a projection. My where takes in a predicate. My first takes in either nothing or a predicate. And that's about it. Or, sorry, all takes in a predicate, or any takes in either nothing or a predicate. One stipulation, or two stipulations, you may use iterator blocks, but you may not use LINQ. Okay, so let's go ahead and flesh out a few of these.
Yeah,
my select is going to be, the signature of my select is going to be something like this. Well, actually, I already have this written. Whatever. Signature of my select is going to look like this. I'm actually just going to write their signatures. I'm going to go ahead and say blah, 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 blah. IEnumerable, T result, my select, T source, T result, IEnumerable, T source, func of T source, T result. Okay, so this is the first one, my select. The next one, my where, is going to look like this.
Are you not missing a... Well, you are missing a... single brackets.
My where will look like this. Blah, 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 blah.
Boo.
Predicate. Okay, my first is going to look like either this or this. All.
Do you mean...
What?
Do you mean or? You said it's going to look either like that or like that. Do you mean both?
Yeah, both.
It's going to look like both of those.
Yes, both.
Yeah.
All is going to look like this. Any is going to look like either this or like this. Okay.
You should make them do aggregate.
No, I'm not that mean. Okay, what does my select do? I'm actually going to go ahead and do proper headings on this because the formatting is really awful. Okay, my select for every item in source, return the result of applying the projection predicate. My where, for every item in source, return only if the predicate returns true when applying the item. First,
just to clarify, what is returned is not true or false that's returned.
Yeah, return the item only if the predicate returns true when applying the item to it. Okay, returns. First, we'll return the first item of the enumerable. Throws an exception if the enumerable is empty. This first will return the first item of the enumerable that matches the predicate. All return true if all items in source match the predicate. Any returns true if there are any items in the source. Any with the predicate will return true if there are any items in the source that match the predicate. And then let me go ahead and add the my prefix to all these. And yes, exception handling was talked about in 102. Okay, one thing to note, I am not expecting, I'll just write this out, not expecting people to validate parameters. And here's why.
Even parameters.
To validate arguments. Okay, here's why. Because of the nature of deferred execution, the only way to, for example, let's say my filter method, I wanted to check to see if that was null. I want to say if that equals null, throw new argument exception, or argument null exception. Now, while this code would work, remember that it'll only throw this exception on the first time it hits a for each loop, which means that for every LINQ method that you're going to be re-implementing that needs validation, you actually have to split it into two methods, one that actually has the iterator block in it and one that actually has the validation. Because that'll add a bunch of noise into the code and the homework, I'm not going to worry about that. So don't worry about validating the arguments.
Do you want to go ahead and specify the name of the class to put them in and everything, and just be done with it?
All right. Now, if you guys want to have some fun, go ahead and also do things like, for fun, we always have things like, don't worry about the math operators like sum, because those require a bunch of overloads that I'm not going to even worry about. But for fun, you can do
equality,
aggregate, you can do sequence equals, stuff like that, or do the last or default, single or default, and so on. Re-implementing these LINQ methods is the best way to solidify your knowledge of LINQ. As far as a recommended resource for further learning on LINQ, there is one in particular. In fact, that resource is what I'm kind of basing this entire class around, because it was a brilliant idea done by a brilliant person. Unfortunately, by giving that resource, it would be almost like cheating. So by doing this first step, you are going in the same direction.
We will tell you that next week.
Yeah, well, and if you want to find it yourself, that's fine. But basically, it would be a lot like cheating.
Actually, if you want to find that yourself, then that, more power to you. I mean, because from the point of view of, first thing you do when you don't know or understand something should be to look it up. And I've no doubt that if you found it on Google, somebody else can find it on Google. But
yeah, it's a great series of blog posts, and we will be talking about those next week.
You gate close. Stop. Make sure to copy that.
Yeah, I'll just do that right now. Okay, so how's everybody feeling about this homework? I noticed we lost quite a few people as I was typing that out. I think people are terrified of this. This is going to be very difficult for some people, and I know that. But if you just seriously, just try it. Generics are very, very difficult to reason about when you're not used to that. Chris, I should actually say, I'm not expecting people to validate arguments for iterator blocks. The method that I specified that should throw an exception, my first, it does not need to be an iterator block and will not cause deferred execution, meaning you can do input validation to this method and it won't be deferred. But if you did an input validation to my_where, it would be deferred. Notice the return types. My_where returns an IEnumerable, which typically means it's deferred, whereas my first returns a t_source, which typically means it can't be deferred because of the way it works. Alrighty, so I guess we're about to head off. Next week we will definitely be going over a few more LINQ methods. I encourage people to rewatch this video because this is very fundamental stuff to code that I'm going to be using very, very heavily during all future courses. So yeah.
Homework will be due at the beginning of next week's class. Please don't expect any of it to be marked before that. And you either pass or fail. It's as simple as that. There is a thread. Can you show them the thread?
I do not know what you're
in the
talking
Member Sponsor Lounge.
about. Lounge?
For Member Sponsor Lounge. Master homework submission, bloody something.
Oh, is that sticky that I always ignore? Yeah, there it is.
Mm-hmm. Anyway, go and find this thread and read it. And let me think. Dropboxes. That's interesting. Dropboxes will need to be submitted by Friday at the latest. Dropbox PMs. But that will get. Yes, you need to send me the PM. It will appear on there. You could just do it while you're there, actually, Nelson. Just edit the post so that next to Blender 102 it says whatever the name of this class is. C# 103. Okay. Right. I'll be doing them then. Joy. Yeah. There we go. Sorry, that completely flummoxed me. But yes, I will put. There will be a homework thread up, and it will be good. Yes, you can go ahead and send PMs from now on. Make sure that you get the subject line correct, and that your body just has your email in and does have your email in. And if you don't do all of that, and you send me a PM saying, "Why haven't I had Dropbox set up?" you will get a rude response. Because I tend to go to 3D Buzz when I wake up while the kettle is on, and I'm not a morning person. So there we are. That's me done.
Okay, so I think we're about to head off. Yeah, fun stuff. So goodbye, future people.